419 battleships in a board. So you're given M by N matrix board, which is really a 2D array. And so each cell or each value is either X or a dot or a period. So you have to return the number of battleships on the board. Battleships can be placed horizontally or vertically, meaning they're not going diagonally, and they can only be a number of rows or a column in a row. So for example, 1, X is just one cell, but it still counts as one battleship. And then over here on column 0, 1, 2, 3, on column 3, for X0, 1, and 2, this is another battleship. And so the way that I would go about solving this is very straightforward. So you're going to have to do a nested loop because you're going to have to go through every row and every column. So for all X and Y values. Within that nested loop, see if the cell you're on is an X. If it is an X, the first thing we're going to do is increment the answer by 1, and then send that X and Y to DFS to be processed. And essentially it'll take the board and all of the X's that are either in a row up or down or left or right, it's going to update those. And then at the end, you are going to return the answer. And the logic for the DFS, it's going to be a void. So first you're going to check if it is out of bounds for this matrix and check to see if it's an X. And then if it is an X, change the X to another value, like I'm going to change it to a tilde. And then you are going to recursively search. So you're going to go up one row. You're going to go back one row. And then you're going to keep X the same. And then you're going to go one column up and one column back. So you're going to search. And one of the key things that makes this work is that the battleships are only going one direction and they're not touching. And so once you get through that, you are going to return the answer. Okay, so let's see what this looks like visually. Okay, so this is what the 2D array looks like. There is 2 boats. One is on X is 1, Y is 3, 4, 5, and the second boat is where Y is 1 and X is 3 and X is 4. So we start off with our answer equal to 0. We are going to have a DFS method that will be there once we find an X. So first we're going to do our nested loop starting with X is 0. And then we are going to have Y equals 0, check if it's an X. Y is 1, check if it's an X. So for this entire row, we are not going to find an X. So Y is going to be 0 through 6, and we are not going to find an X. So then we are going to increment X to be 1, and Y is going to be 0 again. We still haven't found our X. Y is 2, Y is 3, and we finally find an X. So what do we do when we find an X? We are going to send this X and Y to DFS. Before we send it to DFS, we are going to increment our answer to be 1, because even if this boat is the size of 1 by 1, it's going to increase our answer. And then we are going to start our DFS with X equals 1 and Y equals 3. The first thing we're going to do is we're going to change that X to be a tilde so that we don't keep searching on it. So we are going to take that X and Y on that board and we are changing it to a tilde. And then we're going to have a bunch of calls to DFS. So what's illustrated on the right here is our call stack. We are going to send to the call stack x plus 1, which is 2, and then keep our y the same as 3, x minus 1, which is 0, and keep our y the same, which is 3. We're going to then keep our x the same at 1, y minus 1, which is 2, x is the same as 1, and then we are going to have 4 as our y when we add 1. And then we're going to recursively call DFS with these new values that we sent. If we find an x, we're going to add to our call stack. 2, 3 is not an x, so we checked that, and it's going to break at that point. It's not going to add anything to the call stack. Then we are going to send 0 and 3 to DFS, and that isn't going to be an x also. So that's going to just stop right there. It's going to break, so we take that away too. We don't add anything to the call stack. Then we are going to take values 1 and 2, and we're going to take that away from the call stack. And then we're going to look at value 1 and 4, check if that is an x. It is an x. And so what we do there is we follow the same steps that we follow if we find an x. We change that x to be a tilde. And then we are going to go up, down, left, and right from that x by recursively calling DFS, which will add these values to the call stack. So we are going to take x and add 1 to it, which is 2, keep y the same, which is 4. We are going to take x and minus 1, which is 0, keep y the same, which is 4. Then we are going to keep x the same and minus 1 from y, which is 3, keep x the same at 1, add 1 to y, which is 5. So our stack has grown, and so we're not done, and we're going to continually evaluate finding the rest of this boat. So when x is 2 and y is 4, it's not an x, so we don't do anything. When x is 0 and y is 4, it's not an x, so we don't do anything. When x is 1 and y is 3, we actually change that to a tilde. It's not an x, so we're not going to do anything. You can see here how it would increase the call stack. It would just keep adding and would sort of continually search unless we change that tilde. So now x is 1 and y is 5. We're going to do what we do when we find an x. We're going to change this to a tilde. So change it on the board that's given to us, the 2D array. And we are going to again add to the call stack. So x plus 1 is 2, y is the same at 5. X minus 1 is 0, y is the same at 5. We'll keep x the same at 1, y minus 1 is 4. We'll keep x the same at 1, y plus 1 is 6. And so we are continually checking all of these values to see if any of them have x. So going through this entire call stack, we'll see none of these values have x. So 0 and 5, all of the other values, 1 and 4 is not x, 1 and 6 is not x. And so at this point, our call stack will be empty, and this will be done with. And so what we are going to do is go back to our initial nested loop, where x is 1 and y is 3, and we're going to continue. So we found our x there, but we're going to just keep going through the 2D array, which means we're going to look at y equals 4 when x equals 1. So we changed that to a tilde, so we're not going to find an x there. Then we're going to y equals 5. And then y equals 6, and that is not an x. So we are at the end of those columns, so we are going to increase our row by 1. So now x equals 2. and y is going to equal 0. So for this entire row, we're not going to find an x, but we are going to search the entire row. So y is 1, y is 2, y is 3, y is 4, y is 5, y is 6. No x's are found, so we're going to increment x one more, where x equals 3. So x is going to equal 3, y is going to equal 0. No x is found, x is equal to 3, y is equal to 1, and we found an x. So again, what we're going to do is go to DFS, but the first thing we do is increment our answer to 2. So we're sending to DFS the x value of 3 and the y value of 1. We are going to change that x to be a tilde, and then we are going to recursively call DFS by adding the up, down, left, and right values from this 3, x equals 3 and y equals 1. So the first thing we do is we add 1 to x, where x equals 4, keep y the same at 1. We're going to take 1 away from x, where x is 2, y is the same at 1. Then we're going to keep x the same at 3, y is going to be 0, x the same at 3, and then y is going to be 2. So off the call stack, we first are taking the values where x is equal to 4 and y is equal to 1. So we find an x right away. So the first thing that we do is we change this x to be a tilde, and then we are going to have to add to our call stack from our current values of 4 and 1. We're going to have to add to our call stack the up, down, left, and right values. So I'm just pushing these numbers up because they are going to still stay at the top, and we have to add to the call stack, so just so that it can fit on the screen. But again, we're taking x and we are going to add and subtract 1 from x. So subtracting 1 from x, we'll have x equals 3, y equals 1, x equals 5, y is the same at 1. Then we're going to keep x the same, where x is going to equal 4. And then we are going to subtract 1 from y, where y is 0, add 1 to y, where y equals 4. So this is our long call stack now. So we are going to take all of these values and use them in DFS and search for an x. So when x is 2 and y is 1, we are not going to find an x. When x is 3 and y is 0, we don't find an x. And we know this because we can see this visually now. The way the board has been updated, there's no x's left on the board. Anything that had been an x is now changed to a tilde. A key factor that makes this algorithm work is the fact that there is going to be no boats that are touching. And so if you go up and down, left and right from a boat and you find an x, like if you find an adjacent x, you know that it's going to be part of the same boat. So if there were boats that were somehow touching, not diagonally, but up, down, left, and right, this equation wouldn't work. So when x is 4 and y is 0, we are not going to find an x. And then for our last values, before we finally break out of this, when x is 4 and y is 2, we are not finding an x. And so then we're going to go back up to our nested loop where we are at x is 3 and y is 2. We are not going to find an x, but this loop continually goes all the way through. So now we are at where x is 4, and we are going to start where y is 0, y is 1, y is 2, all the way up to 6. We are not going to find an x, so it's going to continually search. And then we are going to increment x one last time, where x is 5. And starting with y is 0, all the way up to 6, we do not find an X. So after we break out of this loop, we have kept track of our answer this entire time. So what we are going to return here is the answer equals 2. So that's how many battleships we found, 2. Okay, so now we can code this up. So first I see that this method signature here is asking for an int. So I'm going to define that. I'm going to say my int answer equals 0. If I get through all of this processing and nothing is incremented or nothing changes, I'm just going to return that answer at the end of the day. So let's do our nested loop for int I equals 0, I less than board length, I plus plus, those are going to be our x values, and let's see for our y values or our columns for j equals 0, j less than board 0, and that's going to assume that there's the same amount of columns in every row, j plus plus. So what we're going to do is this object right here. If board I j is an x, is this character capital X, we are going to increment the answer by 1 and send it to DFS. So we're going to say answer plus plus, and DFS, we are going to actually send the board so we can update it, the tilde, and we are going to send I and j at its current state. Okay, let's take our DFS out of this method. We'll make another one. We're going to say void DFS, and it's going to have the board in it, the same board that was initially given to us. And it's going to have an int I and an int j. And so, oh, this is the logic that we had before. Let me get that back, actually. I'm just going to redo it. Okay, I have the character board, and then int I, int j. Okay, first we're going to check if it's out of bounds. So this is a little bit tedious. We're going to say if I is less than 0, or j is less than 0, or I is greater than or equal to board length, and GTH, or j is greater than or equal to board 0 length, or last factor we're checking is if this board I j, it's not out of bounds and it's not equal to x. So these are all of the reasons why we would stop searching. So if it's any of those, we're just going to return. And if it's not that, if it's not out of bounds, so we'll enter this else if I and j are within bounds, and this board ij is equal to x. So if we found another x, this is the list of stuff we are going to do. We're going to change this x to a tilde. So we'll say board I j is going to be equal to this tilde. Oh, also it's board I j. I wrote I there. It's going to be equal to that tilde. And then what we're going to do is recursively call DFS. Why? Because we want to search up, down, left, and right from this particular cell if it is X. And okay, so DFS, it's going to be sending the board I plus 1 and then J. And then we're going to DFS, we're going to send the board, we're going to do I minus 1. And we're going to keep the J alone. Then we're going to do DFS board. We're going to keep X the same this time, which is really I, and we're going to search to the column to the right, and we're going to search the column to the left. So this will add all of these to the call stack, searching up, down, left, and right, and it'll only add it to the call stack if it finds another X. Okay, so really that should be it. Let me see if I have any other syntactical errors. I'm just going to try to run it. And it looks like it can at least run. And let me submit. And it comes in pretty fast. And that's it. Let me just kind of delete all these comments so you could see the code at the end. It's pretty succinct. Okay, thank you very much.